We just learned how to multiply, divide, rational numbers, and mixed numbers. Now let's practice using them in application problems, aka word problems. So a radio station provides 36 minutes for public service announcements for every 24 hours of broadcasting. What part of the 24-hour broadcasting day is allotted to public service announcement? So if we think about 24 hours and minutes, we realize that we're looking at different units, right? So 24 hours contains more than just 24 minutes. So we first have to remember that in 1 hour, there are 60 minutes. So for a 1 hour period, we could fit all of the public service announcements inside of that because 60 minutes is enough to fit all 36 minutes inside of it. But it is asking about how much of the 24-hour day is allotted to public service announcements. So we're trying to fit 36 minutes into 24 hours. Maybe the first thing that we need to do is talk about units on the same scale. So either convert everything into minutes or convert everything into hours. That way you're not trying to talk about one of them in the wrong units. So let's start by taking our 24-hour and turning it into minutes. For each hour, we have 60 minutes. So if we have 24 hours, we have 24 times 60 minutes. So then we're asking how many of the broadcasting service announcements are allotted, stumbling my words here, sorry, how much of the day is allotted to public service announcements. We're talking about a portion of the day, so we want some part out of the full day. So in that sense, we know that a full day is going to consist of 24 times 60 minutes. That's going to represent our denominator. So 24 times 60 is 1,440. And we're saying that out of the full day, only 36 minutes are for public service announcements. So it would be 36 on top. Now, this is a fine answer, but of course, if we can simplify, we should. I see that they're both even numbers, so at the very least, I know they have a common divisor of 2. But maybe instead of writing 1,440, it would be better to write that as 24 times 60 so that we can continue factoring this. I know 36 is 6 times 6, 24 is 6 times 4, and 60 is 6 times 10. Writing everything as factored form will allow us to divide off any common factors, leaving us with 1 over 40. So what part of the 24-hour broadcasting day is allotted to public service announcements? I would say 1/40 of the day is allotted for public service announcements. Now let's move on to the second question. How many 3/4 minute public service announcements can be broadcast in 36 minutes? Now if you think about it, a public service announcement, it's kind of like a commercial. No one's going to make a 36-minute long commercial, not even for the Super Bowl. But maybe they'll spend 3/4 of a minute on each PSA. So how many of these short little PSAs can we fit into 36 minutes? That feels like a division problem. We're really saying 36 divided by 3/4. We showed that when dividing fractions like this, we can totally make a visual to help us understand what the answer is, or when we found a common denominator, we found a quick pattern, which was multiply 36 over 1 times the inverse of 3/4, so multiply that by 4/3. I could multiply 36 times 4, but I'm going to leave it as it is so that I can simplify before I multiply. 36 is actually 3 times 12, and since I have a 3 in my denominator, I can divide off the common factor of 3, leaving me with my final answer, 12 times 4, which is 48. So we could fit 48 public service announcements that are 3/4 of a minute long into 36 minutes of the allotment for PSAs. And we can double check our work, right? We know that 3/4 should be able to multiply by 48 to get back 36. So if we multiply, maybe we want to simplify first. The 4 in the denominator from the first fraction can divide off with 48 because 48 is 12 times 4. So we're left with 3 times 12, which is in fact 36. So we definitely found the right answer there. To finish that completely, I would say 48 3/4 minute PSAs can fit, not can't, but can fit into 36 minutes. And then that one would be done. Moving on to the next one. We have 35.5 yards of material available to make towels. Each towel requires 3/8 a yard of material. How many towels can be made? So if we had a smaller amount of material, let's pretend we had 3 yards. Well, we could look at that as 3 on a number line. And the question is, how many towels can we make if each towel requires 3/8 a yard of material? So what I'm going to do is find 3/8 on the number line. So my first tally mark would be 1. If I cut this into 8, and then I count up 3, that's 1 towel. If I count up 3 more, that's 2 towels. And if I continue cutting this number line, I can count how many towels to make. So 3 more, 3 more, 3 more, 3 more, 3 more, 3 more. So if we're looking at 3/8, we could count it up this way, but notice that it's really asking how many times does 3/8 fit into 3? That's a division question. So we don't want to draw 35.5 on a number line, but now that we understand its division, we can just use our division shortcut. We're really looking at the question of 35.5 divided by 3/8. To do this division, I'm going to recommend that we turn 35.5 into an improper fraction. So 35 times 2 is 70, plus 1, that's 71 halves. And we're dividing that by 3/8. When two fractions must divide, don't ask why, just flip and multiply. So 71 over 2 times 8 over 3. If we can reduce, we ought to. 8 is 2 times 4, so we can divide off a common 2. 71 is not divisible by 3, so that's the best we can do. We'll do 71 times 4 to make our numerator. That's 284, and then 3 is the denominator. Now we can check to see if 284 is divisible by 3, but Pretty sure it's not, because 3 didn't fit into 71 and 3 didn't fit into 4. So the best we can do would be turn this into a mixed number rather than an improper fraction. So how many times does 3 fit into 284? We can write it as a division algorithm. 284 is equal to 3 times some number plus some remainder. 94. 3 times 94 is equal to 282. And then we would need to add 2 more as our remainder. So we can make 94 full sets, but then we would need 2 out of 3 pieces left to be equal to that same improper fraction. So 94 and 2/3. So if the question's asking us how many towels can be made, we turned that into a division problem. We found the answer would be 94 and 2/3. I don't think any of us want to use 2/3 of a towel, so we would say we can make 94 towels. The next question is how much material would be left? And it's really important that we interpret the answer correctly. We left off the 2/3 here because we're not going to make 2/3 of a towel. And a common mistake would be to say 2/3 of a yard is left over. However, this 2/3 is 2/3 of a towel. Not 2/3 of a yard. A towel is only 3/8 of a yard. So we're actually going to need to calculate what 2/3 of 3/8 is. And remember that we can do that on a number line. If this is 0 to 1, I can divide it into eighths. Whoops, I'm going to move my 1 so that I actually have 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Good. And then 3/8 only goes up this far. But we want 2/3 of that. So we would need to cut 3/8 into thirds and then take 2 of them. That would be this mark. So if we're looking at a full yard, 2/3 of 3/8 is actually equal to 2/8. We have 2/8 of a yard left over. We could check that with using our multiplication for fractions. 2/3 of 3/8 means to multiply 3/8. Before we multiply, check and see if you can simplify. I'm going to have 3 on top and 3 on bottom. I'm also going to have 2 on top with an 8 on bottom, but 8 is 2 times 4. So I can cross my 2's off, leaving behind 1/4. 2/8 is the same thing as 1/4. So visually, we found the answer to be 1/4 of a yard. That's how much material will remain. Then using the shortcut algorithm, we can confirm that's true. With these type of word problems, it's really important to do more thinking than just picking out the numbers and multiplying or dividing. We really have to think about what the number represents and how the physical representation can help us make sense of what the answer should be. One more application. We've got a bookstore with a shelf that's 37.5 inches long. Each book that's placed on the shelf is 1 1/4 inch thick. We want to know how many books can be placed on the shelf. So we're essentially asking how many books can fit into the shelf. That sounds like a division problem. How many 1 1/4 can fit into 37.5. Or in other words, 37 1/2 divided by 1 1/4. Let's turn each of our mixed numbers into improper fractions. So we'll do 37 times 2 to get 74, plus the 1 that's already there, we have 75 over 2. And then 1 1/4 would become 5/4. And remember, when we're dividing fractions, we just flip the second fraction and multiply. Really important that you flip the second fraction, not the first one, and then multiply. I see some factors that will reduce. The 2 and the 4 leaves behind a 2 on top. The 5 and the 75, let's see, that'll leave 15 behind in the numerator. So 15 times 2 would give us 30. So we can fit 30 books on the shelf.